A fairly standard question here, just to find the magnitude and resultant of forces acting around a point. First thing to do would be to split all your forces into horizontal and vertical components. So if we start with the 7 newtons acting at 30 degrees, the vertical component using trigonometry would be 7 sine 30 degrees, and the horizontal would be 7 cos 30 degrees. If we look at the 2 newtons acting at 60 degrees, you'd have 2 sine 60 degrees and 2 cos 60 degrees acting at the horizontal. And finally, the 5 newtons acting at 50 degrees, the horizontal component would be 5 cos 50 degrees, and in the vertical 5 sine 50 degrees. The only thing remaining to do now would be to find the resultant force in the vertical in the y direction, taking upwards to be positive, and in the x direction, taking right to be positive. So in the y direction we have 5 sine 50 degrees plus 7 sine 30 degrees minus 2 sine 60 degrees. Inputting this into a calculator, you should find that this equals 5.5982 newtons. Taking the x direction, left to right as positive, we have 7 cos 30 degrees minus 2 cos 60 degrees minus 5 cos 50 degrees, and that should come to 1.8482 newtons. So obviously you can see that there is going to be some kind of movement in the positive x and y direction. To work out the resultant, we just create a right angled triangle. So in the x direction we've got 1.8482. In the y we have 5.5982. And to make our right angled triangle we can create a hypotenuse, which we'll label r for the resultant. So using Pythagoras' theorem, because we know that this is a right angled triangle, we have the resultant squared must be equal to 1.8482 squared plus 5.5982 squared. So we square and add, square root our answer, the resultant should be 5.9 newtons.